Someone say yes?
Yes.
Okay, thanks. All right, so when you're clustering, remember we talked about there's no absolute way to say this is the right number of clusters. Now, there's some techniques out there that we'll talk about briefly in a second, the Akaike information criteria and the Bayesian information criteria, which can be useful. You can also gain insight, as we discussed, by first starting out with a hierarchical method where the clusters are nested, looking at the agglomeration schedule and trying to spot jumps in the agglomeration schedule. And based on an intuition or a business perspective on how many clusters you can handle and the size of the data, you can get a reasonable range of cluster solutions to consider, and then dig deeper into those cluster solutions. And since they're nested and hierarchical, you can look at each stage and say, okay, these two clusters were combined on this stage. Yeah, based on their means in the variables that you're clustering with respect to, it wasn't a bad idea to bring those together. You look again on the next stage, and maybe now you're looking at two clusters where the means were much different on at least one of the variables, and that would give you justification for saying that's not a step or a stage that was helpful in identifying the different segments within the data. A way to put that all in one picture is just to graph that a portion of the agglomeration schedule. And I'll show you a technique for doing that. So here's an agglomeration schedule for a hierarchical cluster that I ran. And let me go down to the bottom of it. And so remember that these are the distances between the clusters that were joined on each stage. Big jump going from 2 cluster to 1. What I'm going to do is copy a portion of the agglomeration schedule. So I'll activate the chart by, oops, sorry about that. Let's see if I can get this so I'm not, it's not grabbing it. Anyway, so what I'm going to do is go from the bottom of the chart, and I'm going to cut and paste the coefficients at the bottom of the chart, say from the first, from 1 cluster to 20 or so. So I'll cut and paste these, and I'll put them into, and I'm not going to be able to get to the bottom just because of the way this particular laptop's not letting me grab it. There we go. All right. Now, sorry about that. Try it again. Okay, there we go. So I'll just copy like from clusters 1 to 20 or so. And then I'm going to paste that into an Excel sheet. And I've actually already done that. So here's the coefficient from 1 cluster. I'm going from 2 to 1 and so on. So I've got about from 1 to 20 clusters in here. So I copied that portion of the agglomeration schedule. I just put an indication here of how many clusters I had at each stage. And then all I did was do a line graph. And so as you can see, all the line graphs is doing is say when I've got one going from the 2 to 1 cluster, there was the distance between them. And one way to see a reasonable range on a number of clusters is to look at the elbow of the agglomeration schedule. And so right in here, we're seeing that we're getting this diminishing returns on going ahead and putting the clusters together. So if you remember when we looked at that example, from about 8 to 5 or 4, those were seem like good cluster solutions. And then you're seeing the same sort of thing in the elbow and the curve here. So there's no absolute true elbow in this curve, maybe around 5, but it's giving me a visual indication of a range of solution. You can certainly see that you start seeing bigger jumps in the agglomeration schedule around 8, and certainly going from 4 to 3 and 3 to 2, you get big jumps. So right in here is a good place to start investigating cluster solutions. So again, all that is a visual inspection looking for the elbow range, where again, that's kind of a diminishing return. Same sort of thing we saw on the eigenvalues when we're doing factor analysis, is you're looking for that range of reasonable solutions. And then you're going to dig in and look at how the means from the different clusters change by looking at the means table, as we did in class. Okay. Does that make sense? I mean, there's not an exact science on this. It's just a visual way to help pull out the features of that agglomeration schedule. Now, let me close that window. All right, also when you look at clustering, if you note, there's the k-means cluster, which we used at the end after getting the number of cluster solutions. Hierarchical gave us the range of the cluster solutions. There's also a method called two-step in SPSS. And what this does is it essentially creates a tree of cluster solutions and then evaluates those based on a criteria, which is something has the same spirit of looking at that agglomeration schedule. And what the two standard criteria for doing that are the Bayesian information criteria, BIC, and Akaike information criteria, AIC. Both those criteria, intuitively, what they're trying to do is say, okay, if we look at cluster solutions which give us lots of clusters, that will minimize mean square error. Neither one really uses mean square error. It will minimize that is, give us like clusters, but we also want to trade that off in complexity. So each of the criteria has kind of a model fit piece and then a model complexity penalty piece. And it tries to pick the criteria, or tries to pick the cluster solution which minimizes either one of these criteria that you decide to use. The Bayesian is looking at a posterior distribution. The AIC is looking at a model likelihood statistic, but both of them are trying to trade off model complexity versus fitting a model well, an underlying assumed model well. If you look at lots of cases with BIC and AIC, the BIC criteria tends to always want to choose a smaller number of clusters, and AIC tends to choose a larger number of clusters than the BIC. It's an interesting thing to go ahead and run after you've done a hierarchical and k-means to see how it agrees, what it chooses, how it agrees with what you've done. And it gives you an extra way to validate. I tend not to use the two-step for the type of data that we have, where it's true segmentation, where we've got high density areas throughout the data set, because they tend to just glump everything together. Whereas if I'm kind of more manually have looked at the hierarchical clustering and then use that to seed my k-means, I tend to get a better solution when I'm segmenting. Now, when there are actually true well-defined clusters in there, and I don't know how many there are, doing the two-step analysis is sometimes a pretty good way to do it. And in particular, if there's a lot of data points. In the cases we're looking at, or the case you're looking at, we have a modest number of data points, in the 1,000. If you've got 20,000 data points or 1,000,000, and you're looking at maybe, there's 80 true clusters in the data, you might want to use a more machine learning, more automated technique like the two-step clustering. But for modest sized data sets that are typical in a market research setting, doing a more hands-on approach allows you to get to know the data much better and tends to produce a better solution for the project objectives than just trying to let the machine do it by itself. So with that, I'm just going to open up and see if you had any specific questions as you have worked on the cluster projects, and see if I can get those answered for you tonight. So anybody?
Hi, this is Kay.
Yes.
I have just a quick question on like the not the validation, but the profiling.
Yes.
Actually, I have questions on validation, but that confuses me.
Okay.
But on the profiling, so we can just use like the crosstabs to take a look at how how the clusters apply to the different like game usage and things like that.
Absolutely, and that's what more than likely what you should be doing. So,
Okay.
for instance, let me just go ahead so I can talk to it, and then you can ask me another question. So remember, these are cluster solutions I developed just with 2 variables. So let's suppose I had, I don't know, let me do a 6 cluster solution. So I might put that in rows, and then I'm going to go ahead and look at all the game types, or at least a subset of them. I'll put those in columns. For cells, I want to look at the percentages for each row, and I've put my rows as the cluster membership. So I want to see if being in different segments or in different clusters affects the rate that you tend to play the games. Okay. And so that's what I've got here. So here's action game. And so this was, again, the 6 cluster solution. So what this is showing me is that this cluster, let's go through and see which one is cluster 5, whichever one that was. Cluster 5 plays the games at a higher rate than the other clusters. Cluster 2 plays at a plays action adventure games at a significantly lower rate than the other clusters. And so this would be a cluster, and we'll investigate in just a second the characteristics of this cluster with respect to the variables used to cluster it. This cluster, you would say, is not a good target if you're going to advertise action adventure games.
So
Go ahead.
the quantities in each of the clusters are different.
Yes, they are different size clusters, absolutely.
And so
go ahead.
would that affect the percentages that you?
No, that's why you want to look at percentages.
Okay.
Right? So you're not going to get distracted by absolute number. Now, this 6 cluster solution, and there is some evidence, maybe I don't want 6 clusters, maybe I want to go to 5 because I've got a relatively small cluster here. But we're going to look in a second and just kind of see what that cluster is. But you definitely want to look at the percentages because you will have different absolute numbers in there. Okay, so since I've mentioned it a couple of times, let me go ahead and get rid of that. Let me put my 2 variables in there. So again, this is the simplified version where I've just used two variables. Oops. Okay, so that cluster number 2, which only had 41 in it, notice that the average for escapism and average for antisocial is very low. So, you know, if I was trying to figure out good names for these, I would, you know, maybe this cluster, and I think it's the lowest on all of them, significantly below the average. So remember, the average for escapism was 3.2 overall, and then 2.2. And so cluster 2 is kind of the disinterested gamer. They're not high on any one of those particular factors. Whereas cluster, let's see, cluster 6, you know, maybe it's high on both of them. And maybe that is more of an intense gamer. This, you know, what I would call cluster 3, because it's high on escapism, relatively average on antisocial. You know, I might say, you know, maybe that would be more of a escape-oriented or diversion-oriented group. And so what you're going to do is you're going to first characterize the clusters with respect to the variables you use to create them. And so, like I said, you can figure out some names, descriptive names, and it might turn, and as you do profile with some of the other demographics, it might turn out that, say, this segment 6, which I call the intense gamer, also is predominantly 13 to 15. And so maybe this is the young, intense gamer. So you might add some other descriptors based on the demographics. So now that kind of helps me make sense out of these other relationships that I'm seeing here. So for instance, the first-person shooter game, notice that, what did I call it? The disinterested gamer, cluster 2. It's the least likely to play that game than any of them. Whereas my cluster 6, the intense gamer, and cluster 3, I think was high escapism, you know, both of those play first-person shooter at a pretty high rate. And there may be, as you scan through, there may be particular games that everybody plays. You know, let's see. Maybe role-playing. Yeah, so this one, there's not much difference between the rate of play. No one plays it, no particular group plays it all that much, and it doesn't vary across groups. And that's the sort of thing you're gonna state is, and I could do that here, is wrestling and brawler games are played at a fairly low rate compared to other games, and there's no particular tendency of any cluster to play those games than any other. Does that make sense?
Yes.
Okay. Okay. So after you've got your clusters, and you're just going to make these tables, you're going to scroll through, you're going to find which type of clusters, which clusters play which games at the highest rates. You'll have some of these games where no one really plays at a high rate, and it doesn't vary among the cluster membership, and you'll just note that. And then,
so when it's got the no action, that pretty much means that they don't play those games, right?
Well, so let's do stealth. So no action stealth. This means they don't play it. So when they ask, do you play it or not?
Right.
That's it. So what you're looking, if you're trying to say, you know, who plays what game, what sort of gamer plays what game, that's what you're looking for, where they play.
Okay. I get that. So instead of using words, if we did the k-means, we'll just use the results of that, right?
Exactly. Yeah, I'm just pulling words up here because it's handy and I just happened to pick them. Yeah, so most of you will have used k-means. You have seeded the k-means using the hierarchical, and then your final solution will be that's coming from k-means. And so that'll be the cluster solution that you're using to do all this profiling analysis.
Okay. So one more question. You said that we need to make a recommendation. So as far as like who plays games and who to target?
Well, and yeah, exactly. So let me go down to the first person again. Okay. So it's clear that cluster 5, clusters 3 through 6 all play first-person shooter games at a pretty high rate. And your cluster 5 and cluster 6 play at the highest rate. So let's look at what those clusters are. It's interesting, what's the commonality between 5 and 6? They're both high on escapism.
Right.
One's low on antisocial, one's high. So what that's telling me is what's driving playing first-person shooter games is not your high or low score in antisocial, but it's that you play games to escape. You're high on escapism. And so if I wanted to market a first-person shooter game, it's that tendency to be high on escapism. So I'm making this up. Leave your troubles behind today, play first-person shooter games.
Okay. I have questions on validation, but I don't know that
I don't worry so much about validation for the clustering. It's a bit complicated, and I'm not really expecting you to do it for this project.
Okay,
because I wanted to put it out there.
I got the first part, but I didn't get the second part too much. So
yeah, the second part is where the work is. Yeah.
Okay, that's my question.
Okay.
Professor Paul here.
Yes.
Yeah, I didn't get that part, like how you make a recommendation that this thing is driving that. Like,
sure. So let me say what I said again, and then you tell me where you lost me. Okay.
Okay.
All right. So I've got my clusters, and then I've looked at game playing behaviors with respect to the clusters. The one thing I note is cluster 5 and 6. They play first-person shooter games at the highest rate
compared to the rest.
Right. Okay. Yeah. So now let me go back and remind myself what those clusters 5 and 6 were profiled with respect to the variables I used to cluster.
Okay.
So the mean escapism. So again, simple example. You'll have 7 or 6 variables you use to cluster, but here, if I look at the average scores for the 2 variables I used to determine the clustering, 3.9, 3.9 or so. So cluster 6 is high on both escapism and antisocial. Cluster 5 is high on escapism, but low on antisocial.
Yeah.
So if I'm thinking, what's driving people to play first-person shooter games? What characteristic? It's not their antisocial score. It's clearly their escapism score. So what I'm seeing is that people who score high on escapism like to play first-person shooter games. So if I was developing a marketing campaign to pull out messages that would appeal to people, I might say something like, leave your trouble, escape your worries of the day, play this first-person shooter game that I've just come up with. So what you'd want to do in marketing is appeal to the characteristics of the people who tend to play those games. So you would appeal to their escapism reason or attitude about why they play video games, as opposed to that antisocial, because that's not a big deal in playing the first-person shooter games.
My actually my bone of contention was like that first person shooter game that might actually like fall under one of the factors. So why are we taking two factors for comparing? Is it
Okay,
not wrong?
so it's the first person shooter is not a factor.
No, it's a variable, but like when we did the factor analysis, that fell under one of the, like it had a high loading.
No, that wasn't in the factor analysis. No, you factored with respect to the attitude questions.
Oh yeah. Okay.
Yeah,
Okay, got it.
Okay, good.
Yeah, thanks.
Yeah.
I got it. Great.
Okay. Anybody else?
Yeah, Professor, I have one question. It's regarding the classification we are doing with factors right now. So we already did that zig part for each of the factors. Do we need to take in consideration those zig part, or that was only for viewing purpose?
So you're talking about when we added something to the factors to be able to visualize them?
Yeah.
Yeah, no, that's a pure tech. I mean, only reason we did that is to be able to visualize where the data was, because there were a limited number of values that your factors could assume, and so you couldn't see their density in a scatter plot. So all that was used for was a visualization. You're not using that in any of your analysis.
Okay, fine then.
Yeah.
Thank you, sir.
Sure.
Professor, I had a question. It might not be relevant, but when you do a cluster analysis, and there are some clusters that don't really show any, hidden facts or something that you can't. So what do you do with that data?
So say that again. I kind of lost you in the middle. Yeah.
So there are some clusters that you end up having, and you always think like, okay, this is not high, this is always average.
Yeah.
Like, do you? Might be a very stupid question, but like, do you actually end up doing some analysis on those clusters?
Yeah, that's a good question. There may not be an extreme case. So there's probably have an average cluster in here anyway. So there's not a true average. Well, this one, cluster one, is kind of the average cluster.
Average, yeah.
Yeah, and that's perfectly fine, because there are a lot of people that are just in the middle. They're not extreme on these, and yeah, so you'd see where they fall, and you can see, at least on a couple as I was scanning through, they're always kind of, they're more interested in the games than the lackadaisical or the disinterested cluster, but they're not as intense as these other guys. And so, yeah, you've got your average player.
Okay.
And yeah, that's always going to happen.
Yeah, so yeah, kind of, yeah.
Yeah, and that's what you might say is, cluster, you might label your cluster one the average gamer or something like that.
Yeah, no point bothering them.
Right.
All right. Also, Professor, like in your report, you said you did a decision tree that kind of showed your client how to target the customers.
Yeah.
Can we apply the same here?
Yeah, so let me talk about that a little bit, because a couple of you asked. So that was a technique I did because of what the client wanted to do. The client ultimately wanted to give short questionnaires to people and try to figure out who they were based on the clustering we had done with another data set. Mm-hmm. And so if we had identified, let's say, these 6 clusters, and you walked up and I wanted to figure out real quickly what sort of gamer you were, I might give you 3, 4, 5 questions and then put you in a category. And that's what that decision tree was, is to try to pull out which questions or which factors most determined cluster membership. Because you're not really, if I said, okay, I've got a new survey, here are their scores, put them in a cluster, the way to do that, if you're thinking k-means, is, okay, I'll figure out their factor scores, and then based on those factor scores, I'll see which center from the cluster solutions that I generated, which center they are closest to. And I'll put them in that cluster. That's kind of a laborious process. So this was just done to have a quicker way of determining cluster membership. I'm not expecting you guys to do that at all, unless you really want to. You can say, okay, well, here's a quick and dirty way to determine cluster membership. That was just for that particular client. They wanted a simple rule for determining what made someone in a particular cluster.
Okay.
Yeah. Anything else?
I do have one.
Sure.
So normally the criteria is,
I'm sorry, I'm getting some echo, so I didn't quite hear what you said.
is it better now?
Now, go ahead and ask your question. I'll see if I can pick it up.
Okay. Normally the parent and the child node should have
Oh, now I can't hear you hardly at all. I'm sorry. Yvonne, if your mic's not working really well tonight, I'm happy to have a separate call with you to try so you can get your question answered. All right, any other questions? Okay, are you good?
Yes, I'm fine, I think. So
Okay, all right.
I have till Monday to ask, so I'm fine.
Yes, you do. We have one more in person. Yep. Chris, you good?
I'm good. Do you know when we will be able to see our grades for?
Yeah, I'll have those to you, I hope, tomorrow afternoon.
Okay,
So
sounds
I've gotten through most everybody, and like I said, my intention is to try to scan all the sheets. I haven't seen anything that that is going to affect your cluster work. Most of it has been pretty much, whether you covered some topic from the factor analysis well, whether you didn't really explain in specificity how the factor scores were calculated, though I kind of could tell. Yeah, I haven't seen anything that has raised any alarm bells for me for your cluster solution, but I understand you wanting to have it. So I'll try to get that to you by the end of the day tomorrow.
All right, sounds good. Thanks.
Yeah.
Hello, Professor.
Yes.
This is Akanksha. So for the clusters, we are doing drop line graphs, right?
Well, that's one way. Yeah. So you're making a decision on how to represent what the clusters are. So that might be a good way for representing, the means on each of the variables that you use to create the clusters. And if you did that, you'd probably see, for instance, on this guy right here, that everything was high.
Yeah.
So that would give you a visual way to identify the differences between the clusters. So sure.
Yeah, I think that is the only way. Is there any other way?
No, other than doing what I just did, scan across and look at this, or visually to look at the drop lines. Anything else you do, any other visualization, is essentially doing the same thing.
Yeah.
Yeah.
Thank you.
Sure.
Yeah,
Hello,
Professor.
I think I'm clear now.
Yes, I can hear you.
Can I bring my question? Okay,
Yes,
great.
sure.
So normally the parent and child nodes, the parent node should be more than 100, the child nodes should be greater than 50. But let's say on our validation set, we get a very good accuracy on the held out validation, that is. In that case, can we then try to reduce the parent and child nodes? Because ultimately we just want our validation data set accuracy to be high.
Yeah. So So there, the 150 is just the default in SPSS. So if you've got a smaller data set or smallish data set, you might decrease those somewhat. But you can, you know, in the best of all worlds, you would have both the parent and the child large so that you're not fine-tuning the decision tree too much towards the data. So extreme case, suppose you let the decision tree split to a single case in each of the end nodes. Well, then you'd have perfect prediction, but that's not telling you anything. So there's that always that balance between the accuracy, which you're going to, if you allow the tree to grow really deep and you decrease the requirement for the parent node for a split and the child node, you'll get higher accuracy, but it'll be so fine-tuned to the data that it's you want it trusted. And that'll even happen with the cross-validation. So what you've got to be careful is being too fine-tuned. Now, the cross-validation can help prevent something silly like that happening. But there's a balance. Generally, you don't want to split into very small nodes. You know, certainly I would never do 5 in a child. 10 is small, 25, yeah, that's about as small as I've ever done, but that was with a pretty smallish data set. And so you just have to be really careful. Yeah, unfortunately, again, there's no hard, fast rule. But the cross-validation will certainly help guard you from splitting too finely.
Thank you.
Sure. And if you have a couple of example trees that you'd like me to look at, you know, feel free to shoot me those, to copy them and I'll look at them. We can always trade a little email discussion about them.
Sure, sir, will do.
Sure. Okay. All right. Everybody else good? Well, all right. Well, have fun finishing up. Again, the cluster analysis project is due on Wednesday, and that'll give you some time, and we'll have one more opportunity for face-to-face questions. If you're doing the decision tree presentation, you'll do that during class or a regular class time on Monday. All of those of you who are going to do the presentation, please send me a quick email saying I'm doing it. Right now, I think I've gotten 2 people that have definitely said, yep, I'm going to do that project. And if you haven't emailed me, please do that. So make sure that we don't run up against time constraints during class.
One
Sure.
quick question. What are the expectations for that presentation from the trees?
So it's, you know, in the project description, you can see, so, you know, what I'm looking for is, you know, introduction, here's the problem. So kind of think of how you would write the report or do a presentation. And here's the problem. Here's a quick overview of the results, so kind of an executive summary in 2-3 slides. Then a description of your data, the techniques you use, in this case, the decision trees, which one you use, carved shade. You know, mention that you did both. You decided on this because it seemed to provide the better result, more intuitive result. Any validation techniques you used, which you will, the results of that validation, an estimate of the risk, and then an overview of what the tree is saying the most important variables, how well it performed, and then a wrap up if you want to say, you know, if there was more data of this type, we could have predicted better or not. So, you know, kind of the same way you structured your reports, just an abbreviated version of that. And as I mentioned in class, 15 minutes or so should be all you need. So practice to make sure you can kind of stay at 15 minutes. And the kind of the rule of thumb is a slide a minute. And so if you got 15 or so slides, you're probably at the right time.
Okay, thank you.
Sure.
Hi, this is Meg.
Yes, Kay.
This is just an observation that I had. I'm not sure I'm going to do the decision tree project, but I was just kind of playing around with it. When you put in the variables to do the tree, are you supposed to put in like variables, like like the means and by themselves and the standard deviation by themselves, or you put them all together?
You can throw everything in.
Okay.
Now, what you might, of course, some of those are related to each other, but what you're hoping is that the decision tree will help sort it out, or as you do it, you're gaining some insight into which variables are important. Because what you don't have in this version of SPSS, the decision tree, is the ability to look at either the Gini index, well, in this case, either the Gini index or in CHAID and the chi-square score. You can't actually see the scores for the different variables. So you don't know if, I'm going to make this up, if a mean for one of them came in and the chi-square score was 0.001, and then the mean for another variable, it was 0.0009. So it might have chosen the second one, but the first one made a little bit more sense. And so you could substitute one for the other. So you can't, in the standalone decision tree product that SPSS produces, you can do that. You can manually create the tree. So you can't quite see, this mean over that mean or the standard deviation. You can't quite see the relationships. So you're at a bit of a disadvantage of kind of sorting through the variables, like what we did for the regression project.
So are you talking about when I put it in that information in a nice little table?
No.
No? Okay.
No. So for this project, if you threw them all in, try different trees, different number of parents, or different size of parent node, child node.
Okay.
Then you'll get an intuition of which variables are important. But it's not that more structured process that we use for regression.
Okay. I just found it interesting because I did play around with that, and I was getting different answers. So I just.
Yes. Yeah. Depending on, if you put blocks of variables in, you will get different answers. You get different trees. You throw them all in. Like I said, you may see some results that you kind of scratch your head, why that variable and not another. And, it's probably in the 5th decimal place for the chi-square score.
Okay.
Yep.
All right.
Yep. Good. But the trees are a very powerful tool and becoming used more and more. And as I mentioned in classes, it's because they can find features in the data that are hopefully real, but they can find features in the data that are hard to find for model-based methods like logistic regression. And that's why they're becoming more used. And they work really well with large data sets.
Okay.
Okay, well, good. If you have any questions that come up as you're getting your presentations together, if you're doing that, or as you're writing up your results for the cluster analysis, let me know and I'll get back to you. All right. And if I don't hear from you, you guys have a great weekend and I'll see you Monday evening.
Yep. Good night.
All right, everybody.